Greetings, class. My name is Matt Hahn, and this evening I'm going to be talking about hydrophilic and hydrophobic substances and talking about the definition, the characteristics, and how they interact with water. I'll do my best to put this in layman's terms. Frankly, I'm a bit of a layman myself. It shouldn't be too hard. And where I'm going to start is with hydrophilic molecules or substances. At the molecular level, the way that I would describe a hydrophilic molecule is when a substance readily forms hydrogen bonds with water. This also means it can easily dissolve in water and is known as water soluble. Hydrophilic actually translates into water loving, and so that's what that word means. Examples of water loving or hydrophilic molecules include sugar, starch, cellulose, and salt. Some of the characteristics that I'll tell you about for water-loving molecules, I think most importantly, they possess regions of both positive and negative charges. This means that they are polar at the atomic level. Another way of saying this is it's uneven chemical bonding that they have. And as I mentioned earlier, they are water soluble or they easily dissolve in water. And these hydrophilic molecules readily form carbon bonds with water and therefore, as I mentioned, dissolve easily in water. The reason for this is water is also polar, where there's a slight positive charge on the hydrogen atoms and a slight negative charge on the oxygen atom. So water also has uneven bonding, and that's why you have a match with these water-loving molecules. I think a layman's example, an example that we see in everyday life would be when you dissolve sugar in your coffee. Coffee is primarily water. You want to sweeten it, you add sugar. That sugar easily dissolves in your coffee. When we talk about hydrophobic molecules, hydrophobic, a little bit more of a familiar term. Water-fearing molecules is the literal translation. And just as you'd expect, intuitively, it's kind of the opposite of hydrophilic, right? So hydrogen bonds are not readily formed with water because it's a non-polar molecule. Examples of non-polar molecules include lipids, fats, oils, waxes, phospholipids, and steroids. As I mentioned, they're nonpolar. This means they have an equal or a neutral charge at the atomic level. Again, another way to say this would be they have even bonding. So unlike the hydrophilic, which is uneven, this is even bonding, and therefore these molecules do not dissolve in water. They're insoluble in water. You could even say that hydrophobic, when you talk about interaction with water, hydrophobic molecules actually repel water. This is because there's an equal charge across the atom. They don't readily form those bonds, and they don't mix. And so that old adage of oil and water, they don't mix. If you pour oil into a glass of water, and you'll see that they'll be completely separate. You can stir it and blend it as much as possible, and as soon as the movement stops, the oil and water separate again. And that's probably the simplest example I can provide of a hydrophobic molecule. So I hope that definition or those definitions and explanations were clear. I appreciate your time, and I want to thank you for taking the time to listen to me.